This is the Lewis structure for selenium hexafluoride. Let's start with the valence electrons. So selenium has 6 valence electrons because it is in group 16. And then fluorine has 7 valence electrons because it is in group 17. But we do have 6 fluorines. So 7 times 6 is 42. And when you add them together, you get 48 valence electrons total. Selenium is the least electronegative, so we would put that in the center of our Lewis structure. And then we would put the fluorine on the outsides. So we know we have a total of 48 valence electrons. We would put bonds between the selenium and the fluorine. So now there are 6 bonds, and each bond represents 2 valence electrons. So we know we've used a total of 12 valence electrons. And now we will go outside the fluorines to fill in the rest of the octets for fluorine. So now when we look at our Lewis structure, we see that we have 48 valence electrons, which is what we needed. And if we look at each fluorine, we know that they are all symmetrical and they all have a full outer shell and cannot break the octet rule. And the selenium atom actually has 12 valence electrons around it, but that's okay because it is in period 4 on the periodic table. And you can hold more than 8 valence electrons in its outer shell. So this is the Lewis structure for selenium hexafluoride.